So the subject that I was actually asked to put together is a Java SE State of the Union to open the Java track. And it's an interesting thing because this is not the typical thing I'll speak about. Most of my talks tend to go into technical detail, and I like to make a lot of fun comments about technical things. This is sort of a State of the Union thing. So I tried to fight my tendencies to put in commentary about technical things, but it'll still happen here. Looking at what we're going to cover, I'll do a brief introduction of who I am and where I come from. We'll talk a little about history, then we'll talk about some more history and futures. We'll talk, about trends in Java State. And then I'll do some of the obligatory what is in Java 9 stuff, but in a little different way. And we'll go in, I'm hoping to have some time to chat, to actually open it up to discussion so people can comment on what they think about the State of the Union for Java. About me, I'm the CTO of Azul Systems. At Azul, we make Java virtual machines. I've been playing in that game for about 14 years now. One of the things we're probably known for at Azul is garbage collection. We believe we've solved garbage collection. It's a done deal. I've been working on that problem for a while. And here's some evidence of me actually doing work on the problem. That is a physical garbage collector problem. It actually had a bug in it. That machine is a trash compactor. It's in my kitchen. Because I'm a lazy software engineer, what it actually does is it performs minor garbage collection compactions during the week, so I only have to do the full GC where I pause, take the bag out, go outside once a week. And since we know, like once a week, you restart everything once a week and nobody knows anything happened, right? But I had a problem here. The compaction function wasn't working. You see the fragments coming out the back? So it wasn't defragmenting correctly. And I had to open it up and yank the fragments out and reset the compactor. And I thought it would be funny to take a picture with the actual garbage collection theory book at the time. But the really useful piece of information here is that's a picture from 2004. And I've been thinking this is funny for that long. Or more, I'm really lazy. I just don't redo my pictures. If any of you, how many of you have seen any of my talks before? So you've seen this picture, right? Okay. I really need a new one, but I look different now. So, anyway, I have a long history of building all kinds of things. Before Java, before JVMs, I built physical machines and virtual machines and operating systems and interesting little hardware for all kinds of weird stuff. I helped design CPU instruction sets and OS kernels and firewalls and network switches and subscriber management systems for millions of people and built an app server accidentally. And did a lot of weird things that ended up with a lot of mistakes. And I learned from some of those mistakes. One of my hobbies is actually to go around depressing people about some of the mistakes I know everybody makes because I've made them myself. You might have seen my latency and response time talks on the subject. But in addition to that, I'm a member of the JCP, Java Community Process Executive Committee. I represent Azul there. And by the way, we have an election going on. It's important to vote today, not just for president, but also for JCP EC members. So you get that. I mean, the election is ongoing right now, so if you are a member of the JCP, please vote. I also participated in OpenJDK, contributed some stuff, and actually did something that makes it into Java 9, which makes me pretty proud. So that's me. Now, why am I talking about the Java State of the Union? It's kind of weird for me to do that, because I do think the Java State of the Union is something that, really the project leads are more equipped to talk about as a whole. So think of what I'm going to do as Java State of the Union commentary, right? This is my view from sort of the side, well-involved side on what goes on there. We ship a Java SE platform. It's the only thing we do, so we care a lot and we track this a lot and we think we know what's going on. But think of this as selective commentary rather than here's, this is what's going on, we're responsible for it. Right? So with that, let's look at a little bit of history. Rather than just where do we stand today, where did we come from? How did we get here? What has Java been doing? And a simple way to look at it is, let's look at versions. We started with version 1.0, and we are now in version 1.10. If you look technically inside the JVM, we're still in version 1. It's just been numbering 1.0, 1.2, 1.3. Those are the actual numbers in the JDK inside. Now, those numbers have been switched over the years because marketing people don't like this kind of stuff. So around Java 5, it went from 1.5 to 5 and 6 and 7. So when we talk about Java 9, we're actually talking about Java 1.9. And not only did this kind of naming thing happen, if you actually look at what the platform was called, it started off as Java 1.x, 1.0, 1.1, 1.2. But around 1.2, they decided, okay, 1.2 is a good basis for Java. So they called it the Java 2 SE platform and started counting from there. And then we had 1.3, so J2 SE 1.3. That's, that's Pizza Hut making pizza. And then J2 SE 1.4. And by Java 5, they kind of figure out that contradiction makes no sense. So they went with J2 SE 5, not 1.5. And see, there's a 2 and a 5. And then finally, we dropped the 2, and we're in the Java SE world, which is how we name things today. So these are the historical versions. Going back to what actually went on in those, and kind of zooming into versions in time, 1.0 was the first thing that Java did after the alpha and beta. It was this thing we thought would be used to build applets in web browsers mostly. Nice language, some basic library capability, interesting syntax. But important things were added in the first few releases that made it actually robust and useful on servers. Reflection is one of the things that was added fairly early on. Swing, which we still use for some things, like drawing on desktops, was added around the same time. The notion of a collection, a hash map, a list, a generic way of a way of looking at collections was added in 1.2, and along with that came things like weak references, soft references, phantom references. All these are fundamental changes to the language or the platform. So every time you see one of these, programming once that happened was different than before. You no longer program the same way. Anybody here still use vectors? The uppercase vector, that was a 1.0 data construct that has been eradicated and defunct and deprecated forever, but it's still there, right? It predated collections, but So every time we went through one of these new features, that enabled a dramatic new way of using the language and expanded the ecosystem quite a bit too. So these are big shifts. 1.3 was more of an incremental add more libraries thing. In 1.4, we had a huge shift and capability around NIO. Now, NIO these days is not the sexiest thing, and people like to hate it. But NIO was a fundamental change to Java in that was the first time that in Java, without some native hacking of some C code, we were able to talk to networks with more than one connection per thread. Up to that point, we had a simple blocking API for Java, but with 1.4 and NIO, we had a muxer. We had the ability to wait for multiple things to be ready at the same time and act on whatever come ready, and that meant that we could actually build application servers and containers that directly in Java without any hacking outside the JVM were able to terminate thousands or hundreds of thousands of connections. That was a huge shift because that enables a sea change at how Java was used in servers. Rolling forward to Java 5, generics. A dramatic change to the actual language and how we write things. Up to that point, we did not have generic capability. Collections were simply collections of objects. So we're able to describe generics, type them, have the compiler sort of help us with the times. Again, things we like to look back at and hate because there are many things we wish generics were done differently with, but the capability came in there, and it's still the same to this day in how it works. And that allowed us to really leverage the notion of data structures being things we don't build, but things we get from other people. Good data structures already come with the JDK or are made by other people that know how to make them. And it's pretty rare that you have to build your own data structure. You mostly do stuff like put things in data structures. One of the common, very useful libraries that came up in Java 5 is the Java util concurrent library, which is made up of a lot of interesting things around concurrency and atomics and locks and stuff, but even more importantly, useful data structures. Well-written, scalable, concurrent data structures that you don't have to build, debug, and make work yourself. Whether it's queues or stamped locks or concurrent hash maps. You don't have to build them, they're just there. Which, if you compare it to other environments, the ability to actually just have somebody else like Doug Lee having written all that for you is great, and have it be leverageable. That happened a decade before C++ had similar stability. Moving forward from Java 5, notice I kind of jumped over Java 6. Java 6 and mostly Java 7 were sort of incremental releases from a point of view of how they affect what you do when you program. There was a bunch of very important capabilities and new libraries and XML behaviors and things that were added to the platform, but fundamentally the language itself didn't really evolve or change. In Java 7, the biggest changes to the language was that we didn't have to write things inside the brackets, and it kind of automatically did it, and we had, try with resources. Wow, yeah. But, not, wow, I program different now. That didn't happen with Java 6 or with Java 7. And then we get to Java 8. And Java 8 did this. We have lambdas. We have lambda expressions. We have functional interfaces. It feels modern. It's almost like Lisp, right? And we also had another pretty interesting big capability that came in the Stream API. That allow us to actually program to streams and collections in ways that is more modern and useful to model walking data through them. So these are two big capabilities that came in Java 8 that really changed how people program. If you look at it from the point of view of when developers want a new version of Java, it's usually driven by one of these capabilities, right? Java 6 did not drive strong developer-led adoption, neither did Java 7. Java 8 did. People want to program in this new stuff, which means you push and you make sure that you can actually use it in production. So that's kind of where we are today. Java 8 is the current thing. The adoption of it has been very good. It has been led by developers because we want to program to these new features. And we've pushed that way. What does it look like going forward? So Java 9 is around the corner. It's right around the corner. The corner keeps getting a little bit further. But it's not that far, right? And the feature set is pretty well known, and a lot of work has been put into it. It's not just a culmination of work since Java 8. Java 9 actually has things in it that have been worked on for 2 or 3 releases and took that long or are taking that long. But Java 9 is a fairly incremental release from a point of view of language behavior. I see it much like Java 7. What happens to how you program in Java when Java 9 comes out? I mean, there's really, really cool stuff in there and all kinds of new capabilities and libraries and methods and things, and Stream API is getting better. But fundamentally, there isn't something you'd say, aha, this has just changed everything in how I write. Most of the features that we're actually getting excited about and looking forward to are not in Java 9, they're happening in Java 10 and beyond. Now, yes, obviously there's this jigsaw thing everybody knows about in Java 9, right? Jigsaw and modularity. And we can talk about what it does, but does it actually change how you program? No, I mean, it doesn't even change your code. It changes the way you declare other packages and the way you package your own stuff. And it's good housekeeping. Very much good housekeeping for the JDK, but it's not fundamentally going to change how you program. The actual changes are probably going to come in the future with things like value types. Value types, for those of you who don't know, are the ability to take things that are not quite classes, but code them like classes. Things like X, Y's for points, or small structures. It's a struct-like behavior. The ability to pass and move around tuples, return tuples, pass tuples, without the cost of full object overheads. And arrays of them and such. So really useful capability. We've been waiting for this for a long time. And it's looking good in development. This is a real thing that is really being built, just not for Java 9. Then we have things like Arrays 2.0. Arrays 2.0 is a catchphrase for all the things we want arrays to do different than they do today. But to give you a feel for what it means, It's everything from finally having arrays that have more than ints as indices, because it is 2016 or 2018 by the time it'll happen, to the ability to have arrays of things that are not just primitives or references, to the ability of having arrays that might be sparse, might vary in length, might have all kinds of interesting behaviors like columns versus rows versus columns and layout. All this, there's a bag of all the things we want to see. And if you actually are interested in some of that detail, there's a great online recording of John Rose talking about Arrays 2.0 at the Java Language Summit from, I think, 3 years ago. I encourage you to look it up and see what that is. And, oh, I got ahead of myself with the Arrays 2.0 there. So that Arrays 2.0 will come. We also have interesting work on what's called JNR FFI, letters and letters. This is the foreign function interface, which is fundamentally the ability to go and talk to native code without having to write all the JNI stuff to do it. Think of it as, here's an H file for C stuff. I want to call that function. And that function might have a struct that it takes as a parameter. I want to be able to talk about that struct as well. And FFI is going to allow us, hopefully, to make those kind of calls much more easily to kind of discover and include non-Java interfaces and be able to translate from Java to them without having to do a lot of the mechanics and code and stuff. There's some very promising work going on for that as well. In addition to that, we probably will see some changes to the language itself. For example, there's some interesting debate and talk going on about adding the concept of vals and vars to declaring of variables in Java. Some people think this is great. Some people think this is going to ruin the language. I'm sort of on the fence. But this is certainly in our future for discussion. And then a lot of we don't know yet that goes on and on beyond that. So that's where we are from a timeline perspective. As a highlight, I pick and choose a few things to focus on. And I mostly look at this as things that affect how you program. Notice that adding a new XML parsing library or the fact that we don't yet have a JSON parsing library in Java, I'm not talking about there. Those are, you add them to the platform, you standardize them, or you get them on Maven from 17 other implementations. The ecosystem we have is huge. What's spec'd and standard or not is not that much a concern, but is the language as a platform actually evolving to enable new things is what I focus on here. Now switching from looking at the timeline, usually when you want to talk about the state of the union, you want to know how the union is doing. So how is Java doing? And often when people ask that question, these days, they ask these kind of questions. Is Java still popular? Are there more cool things out there that are displacing Java? Is it trending away? Is this COBOL? And I like to say Java is COBOL, but it's COBOL in the 1960s. It's the coolest thing to program in still, or the most safe thing to program in. Now these are all valid questions, and they occur, and they have occurred since Java started. I've heard these questions come and go since about 2000. There's this really cool new thing now that will displace Java, and people are writing in. It's called Perl and PHP and the LAMP stack. That's just taking over the world. And then Ruby and Rails. Oh boy, we build everything in that. We build Twitter in that, right? And then there's the next new thing of JavaScript and Python and Go. And these are very cool things. That's what people program a lot of cool things in today. But whenever one of these has come and gone, they've come and gone and replaced each other so far. We haven't yet, in my opinion, seen the thing that is displacing Java. We will see it. Someday it will come. When we see it, we'll recognize it 3 years after the fact when Java has actually started to wane and this other thing is taking over all of its functionality. But I don't believe it's happened yet. Now, to look at some examples of actual data, and these are current data to 2016, this is a language popularity on GitHub chart. And yes, JavaScript is the most popular language on GitHub. What's the number 2 language? It's Java. And what's the one with the highest growing trend in the placement? It's Java. That's actually surprising, given what we hear about the other things, right? If you look at jobs job availability, jobs that contain requirements. Java is pretty far up there. I'm not sure what SQL is doing there quite. That's a website I just looked up, right? But Java is a very popular language, and it's being hired for. Lots of people know it. Whether you believe we have 8 or 9 or 10 million developers running Java today, it's the easiest language to hire for. If you want to build something and you want to make sure you can find developers, there's a lot of them. Not all of them are good, just like any other language. But within that population, there's a lot of really good developers, and you could hire them. It's one of the safest places to go hire. Now, if we go back to these really cool things that keep displacing each other, has anybody here tried to hire a Ruby developer recently? What about a Perl developer? Now, there are people who know those things, but they want to program in Go today. They want to program in JavaScript. They want to program in Python, usually. There's a trend away from trends that goes on. And the thing that Java has in it, I believe, is the true strength. And a big differentiator is that it's got this 20-year solid history of code that works, code you can hire developers to work on. You can go back to 60-year-old code and work on it and find people that you can hire today that will be able to work on that code. That's a huge, huge ability. Another simple metric. This comes, I think, from New Relic. But it's basically the number of job titles can contain that language in them. And Java is huge in the difference there. But let's look at it a different way. I like to kind of take a look at the 20-year history we have behind us. I have been playing with Java since it was in alpha, since it was this cool little thing running inside a web browser mostly. And to me, the big wow point was when Netscape went on a stage at a Sun Developer Conference and said, we are putting Java in the browser. That was wow, that little cool toy I've been playing with, that might actually become something that's popular. And that was 1995. The next year, there was no Sun Developer Conference. There was Java 1. And it had 4,000 people in it, which was twice as much as the Sun Developer Conference has ever had. And that was a year after this. And it's grown ever since. Now, if you look at how Java took over the world and what the phases of that happened, we really had these 3 phases, in my opinion. We went from introduction in 95 to completely taking over the world of servers by 2001. It took less than 5 years to actually get there, which is why I think that the thing that's displacing Java is not yet here. We would have seen some indication. And when I say displace things, in 1995, 1996, the way to build applications for servers it was in C++, it might have been in Tuxedo, it might have been right directly with SQL to databases. And very quickly, Java, this thing that was coming from clients and just had a few capabilities, started taking over the world with all kinds of things like servlets and JDBC connections and such. We then have an era of applications where applications were built in Java, not in other things. If you wanted to build a new HR application, you didn't go hire people to build it in C++, or in Python, or in Perl. You would go and hire people that wrote in Java and ran on one of these platforms you can easily get. And a lot of applications, whether they were business applications or web applications, were built that way over about a decade. But those were applications. That was what people built for their needs, their function, whether it was a huge web application or not. And in this decade, we had a really interesting shift for Java. Java is being used to build infrastructure. Pieces of infrastructure that are fundamental to everything we run. Now, if we look at what I mean by those, JDBC pools were a really interesting invention and capability that started early on in Java. The fact you could talk to databases with a connection, there was a pool of connections that managed it for you, and you didn't have to basically start a process for every request you got from the web. The notion of servlets. Do you guys remember what we had before servlets? If you got an HTTP request, you forked a new process. Yep, CGI. Servlets meant that the same process just handles things locally and can able to talk to different connections, let them go. And the whole concept putting this together was the basis for what we think of as an app server or a container today. Java EE sort of evolved from that as a set of specs and standards when it was still thin and not kind of thick and aging like we feel about it today. And that led to things like WebLogic and WebSphere and JBoss and Tomcat, which we build applications in rather than build. When I said I accidentally built an application server, that's because I used Java 1.2 in 1998 to build an application. There were no application servers. I was lucky there was a JDBC connection I could use. So we had to build the application server, but by 2001, you didn't need to do that anymore. You could buy one. You didn't have to build that infrastructure, you just build your business logic, and that was great. We evolved into things like portals and web services and SOA and data grids and all kinds of things that really sounded sexy at the time and look old now. And there were lots and lots of technologies in there. But really, applications were dominated by this. And that meant that if you built an application in Java, you just got there quicker. And it was because the ecosystem was huge. Now, shifting into this decade, we have things like Hadoop and Cassandra and variations of Lucene and distributed systems like Solr and Elastic and Kafka and Spark and Storm and Zookeeper and many others. What's common to all of these? They're built in Java. They run on JVMs, even though you don't program them in Java necessarily. Most of them are just pieces of infrastructure that serve some functionality. It just happens that building them in Java was the way to get there, to scale, to dominate the market the way it is. So infrastructure pieces today, the largest databases in the world this decade are in Java, which to me is a huge thing because I remember in 2005 looking around and saying, damn it, why don't, and all the databases are not Java, we only have applications. So this is where we are today. Java dominates infrastructure. It's still very much a back-end application building environment, and yes, there are many, many new cool things that keep evolving and replacing each other to how you build the front ends and how you glue things together. And you know, whether we call the new things microservices or other types of services or all the way to RPC, we reinvent the cool new way to do stuff. And Java tends to fit into those, but there are right, better ways and lighter ways to do things for the right things. Overall, commentary on the State of the Union is it's good. It's not going away. Java is in a really good shape. It has fairly good stewardship. It keeps getting new features developed that are relevant, and it is maintaining its very powerful ability to actually run software over 5 years, 10 years, and still have relevance and the ability to develop it and maintain it. So that's how I look at the state, the history, and where we are. But whenever I talk about one of these subjects, everybody wants to talk about the now and what's coming. So this cool thing, this Java 9, what's in it? So what's in Java 9? Well, there's modules. Modules are in Java 9, and it's going to be modular. But since everybody talks about that, I won't talk about that. It's got modules and some other stuff. And I'm going to talk about some of that other stuff here in the rest of the time we have. So here's a list of everything in Java 9. That's actually from the Java 9 project that describes all the different JEPs on OpenJDK that are going into the platform currently. That's a long list, and I'm not going to get into all of them, so I handpicked a few of them to sort of zoom into a little and talk about. And then those samplings are just interesting, selective ones I've picked. So these are kind of the four, the JShell, var handles, unified logging, and spin weight hits. That's what I'm going to cover here. Let's look at the first one. JShell. Java has a REPL. A REPL stands for read, eval, print, loop. This is a huge invention, very current to 2016. It's very important because practically every modern environment we program in has a REPL, so Java really needs one too, and modern starts with Lisp. Now, the reality is, when you touch this REPL, your immediate reaction is, how the hell did we not have this for the last 15 or 20 years? You know, everything else has it. It's how people play and evaluate and poke at the language of the libraries. Why didn't we have it? And there's no good explanation for why. I mean, really, there's no good explanation. It's one of these obvious, simple things, but this is a great feature of Java 9, the platform. It doesn't change how you program, but certainly makes you be able to poke things interactively much nicer. So you now have a direct link to talk Java to a machine and look at what the code has in it and play with it. That's it. Java has a REPL. Right? You could look at a lot of details. Go look at it online. There are full talks and examples on how to use it. But it is one of the coolest actual usability features in Java 9. The next one is var handles. Now, var handles are actually these technically fairly complicated to code to and not necessarily the prettiest things out there. But they do add capabilities, fundamental capabilities to the language that let us do things that we had to kind of do hackish things around before. And this is the actual purpose of what var handles are for, to let us do things that we right now need to actually use atomics to do, even though we don't need the atomic functionality. Or we need to do unsafe things to do, which is even worse. var handles are really there to help us get rid of our habit of using unsafe to bypass the Java spec. Who here has used sunmisc unsafe? Okay. You're aware that that's not Java, right? It starts with sun.misc. It is not in the spec. Nobody's ever promised that the next version or even dot release of Java will actually have that method in it. But we've all learned and end up being so tied to that functionality for fundamental things in it. There are tens of open source libraries that would not work if it didn't exist, that it's a fundamental part of any practical Java implementation today. That is not a good thing, because unsafe right there tells you something. You know, it was labeled correctly, damn it. Now, I mean, what more than this can you say? That don't use this, stay away, you know, it's unsafe, right? But it has functionality people want or need. Now, I like to break down unsafe into modes. And those modes are sort of the Rumsfeldisms of unsafe, right? There's a safe way to use unsafe. Then there's an unsafe way to use unsafe. And unfortunately, the fact that there are unsafe ways to use unsafe makes the uses of safe sometimes unsafe. And then we have to question whether safe is actually safe. Meaning, you touch one thing with unsafe, you put everything in question. We actually don't know what you have, all verification out the window, all security is on the window. But more importantly, bugs that couldn't exist without this are introduced. This is not fundamentally about security or safety. It's about the fact that fundamental things like actual integrity of the heap and non-corruption that the JVM actually promises and maintains very well go away when you start using these APIs. So var handles actually are meant to a large degree to take the things people are using in unsafe and give them a proper Java way to achieve the same purpose so they don't have to use this API. And the proper Java way will be in the spec, and you can rely on it being in future versions so you can convert your unsafe code to use that. So the purpose is to take unsafe away from you. Now, some of you might have noticed in the last year and some, there was some pretty loud discussion about unsafe going away in Java 9. And you know, is it going away in Java 9? No. I actually think it was a great way to get people scared. I think it was planned. I think they never meant to really take it away. They just threatened to take it away. And then everybody told them about all those things you do with it, so you can't take it away. Now we have a catalog of how people use things. We can make sure we have the right functionality. So 4 or 5 years from now, we can take it away. And that is a good purpose. Unsafe should not have been there to start with. The fact people use it is bad. We do want to eradicate it, but it's not going to get eradicated in Java 9. What it does mean is, if you today are using unsafe, one of the things you should look at is how to get rid of all uses of unsafe by using new features in Java 9. And if there's something missing, complain. Be loud about it. Make sure that we add whatever is needed in Java 10 or maybe in 9.1 or 9.2 or something, so that over time we will not need this API. And I do think this is very, very doable and very achievable, and it's a noble goal for maintaining integrity in Java. Now, there's some other cool things in var handles. One of them, not just about getting rid of unsafe, var handles also finally have a fencing API. We can actually talk about wanting to fence things and order things without having to do a volatile read or a volatile write or a lock or something like that. So you can actually say, I want to fence things so that all loads are not going to be reordered in the future and things like that. These are very useful for concurrent algorithms and to do the cheapest fence you need. And one very important fence that I'm highlighting here is the ability to add what's called a reachability fence that says this thing is actually still reachable and still alive until I say otherwise. The typical use will be in a try-catch like this, or sorry, try-finally block. The purpose of this is to make sure that that object does not die prematurely and cause interesting weird things to happen, like freeing buffers and then having access to free buffers after the fact and things. There's several fundamental places you'll find bugs around this, either in commonly written Java code or even in the JDK itself, that this will help us solve. So that's var handles, and there's a lot of stuff you can find about var handles. The next one I want to zoom into is logging. Now here's a few of the flags that you could do to control various types of logging in the JVM today. And unfortunately, none of these have any standards to them. If you've ever tried to read a GC log, you probably understand how complicated or weird that is and how it changes between versions and by collector and how it might actually be corrupted. But there are all these other things that get logged, and they all get logged with independent, slowly evolving kind of things. In Java 9, we have a common logging mechanism and a common logging regime, and it's controlled by a -xlog flag, and it is spec'd in behavior. And if you want to look at the details and the examples of what that means and how you can filter on them and what the proper way for the formats to look like and all those, you can find a lot of that in this talk that I refer to here. This is one of the important features, I believe, of Java 9. Again, not so much affecting your programming style, but really affecting operations quite a bit. Now, the last feature I want to zoom into is my favorite feature. It's called spin weight hints. And why is it my favorite? It's because I built it. And spin weight hints is an interesting thing, both in functionality and in an exercise of getting something into the code. So what does it do? Spin weight hint basically adds a single method to the JDK on the thread class, and it's on spin weight. And that method does absolutely nothing. It really does nothing. There's no semantic meaning to the method whatsoever. It has no effect on state. It does absolutely nothing. But it does that nothing very fast. Its purpose is to do nothing quickly. Now, why is that important? We have this common pattern that happens in various communication things written in Java, whether they're high performance or low latency or bypassers, or whether it's variations of disruptors or other spinners, where you end up wanting to wait for something and not give up the CPU, either indefinitely, literally sit there spinning on the CPU until something arrives, or temporarily. For example, you want to grab a lock, but somebody else is owning it. You can go block in the OS, but you heuristically say, let's spin a little while, maybe it'll get freed before I go block. That spin will often look like this. And it turns out that that's a common pattern within the concurrency utility in the JDK. It's a common pattern a lot of interesting software people build on top of Java. And the way to use onSpinWeight is simply to put that method call inside your spin loop. It does nothing except to tell the JVM you're in a spin loop. And the JVM can actually use that to do things better. Hardware usually has capability, x86 has capability, for example, to spin better, to spin faster with less power, but more importantly, to react faster. And this is a chart comparing the reaction time to setting a variable on a spin weight when you have that in it or not. The blue line is the reaction time when the spin weight hint is in, and the red line is the current reaction time without it. So across a wide spectrum of percentiles, we get an improvement in reaction time of the loop. That's the purpose of this thing. So that's why we put it in. A lot of people have been asking for it for a while. Now the reason I actually went through this is not just because I wanted the functionality, because we have low latency customers that want it, but also I wanted to go through the exercise of putting a feature into Java 9 that did not originate with Oracle and did not get developed by Oracle, to do the actual community development thing. Let's see what it takes to do it the right way. So we built the prototype, and we had a discussion, and we opened a JEP in OpenJDK and documented it, and then had proposed code and had reviews on it and discussions, and eventually it made it into Java 9, which I'm really proud of. But the cool thing about this is it was an opportunity to measure how long it takes to do the minimal possible thing that could go into a JDK. This is one method that does nothing. You can't do less than this. This took about 8.5 months, 4 of which was arguing about the name of the method. You can go look at the OpenJDK mailing list for the history of that. And it's a really interesting thing to realize there's a huge difference between complaining and saying you want something and actually doing it. There's real cost to this. There's real work involved. Next time you talk about all those things those JDK people don't put in, remember that it is a lot of work to get it right. To put it in thinking about the next 10 or 20 years and needing to maintain it and not wanting to deprecate it in the future. And letting all that, is this the right name? Is it the right functionality? Is it future-proof happen? Because it needs to happen. It's not just, oh, it's a cool feature, why don't they put it in? We need that kind of thing. I'm hoping that this is not the cost per method, that it's the cost more of a project, the minimal entry-level cost, but that's roughly what it does to go in. And I do think, and just asking all of you, if you do have things you want in the platform, work to participate in it. OpenJDK is an open project that allows people to do this. This is a demonstration of it actually running to success. Okay, so zooming out, here's the features I kind of zoomed into. And we can ask the question of, okay, which of all these things are going to make people actually move to Java 9? What's the cool thing that's going to attract them to it? And the reality is I don't really know. And I don't think a lot of other people know. But this is where hopefully we have room for Q&A and some discussion. And we could talk about those questions or any of these cool projects up there that people might know stuff about or want to know stuff about. Good, we're 5 minutes for Q&A and perfect time.
All right, so we have about 7 minutes left for question. There's a couple of volunteers that'll be walking around with a mic. So I've got a first question. So 96, Java came out. A lot of the complaints, released 1.0 96.
Yeah.
So a lot of the complaints that I hear is there's a lot of boilerplate. So people use other languages because it's cleaner. What's the future look like for removing boilerplate?
So the boilerplate comment is an interesting point. Yes, there's certainly a lot of boilerplate in Java, and some of it actually, Lambda expressions did a lot to remove, but there's still a lot others left. For example, that val var thing is an example of trying to use inference instead of being explicit in discussion. I'm fairly opinionated about that. I think boilerplate is really good. I think that readability of code is more important than writability of code because you read it a lot more often. And I find it harder to read inference-based languages because my brain has to do inference than when it actually tells me what it does. But that's a personal taste thing. And you will find very good, strong argument on the other side, too. As far as trends, I think the main thing that's working towards that direction is things like val and var in the language, in addition to additional things that remove and add inference at various levels, making inference for lambdas better and other types. The move towards primitive-based collections, which I put up there and I think I might have skipped talking about, but the fact that you can have primitive keys and collections will probably work to help with that too, because we have implicit boilerplate around the packing and boxing of objects today, and also performance losses.
Great, thanks. Any other questions?
Just to comment, I do agree about the readability. I think your tools will generate a lot of boilerplate for you,
Yep.
and it definitely helps with readability.
Actually, sort of a follow-up on that. I had this epiphany when I write some libraries that I put on Maven, and when I write code, I write it to Java 6 or to Java 7 because I want a lot of people to be able to use it, which means I can't use the cool stuff. So I wrote some code, and because Java 8 is out, I wanted to accept to expose functional APIs, but not force them. I wrote some stuff and built some tests for it, and literally had to kind of comment out the Java 8 tests that they'll run on Java 7 and 6. And then, I upgrade my IDE, and I look at my code, and suddenly my code is full of Lambda expressions. And I'm looking and I say, I don't remember writing these. And I literally had to go, no, it's still commented out. I didn't put this in there. And it took me about 10 minutes to realize that IntelliJ added a feature that auto-recognized the boilerplate, collapsed it down to a Lambda expression on the screen. And now I'm looking at Lambda expressions in my IDE. So the power of that with IDEs is pretty amazing. And I had a panic attack for about 5 minutes before I realized what was going on. It's just, you know, I don't remember doing this to the code. Yeah.
Thanks for the talk. It's great. I love the State of the Union. I'm curious. Like, you have more than 20 years of experience. What's the next like revolutionary change you'd like to see, or what do you expect could be a difference maker? Like, not the empty spaceship operator, but something like generics or lambdas. Like, what do you foresee coming next that could be the next big thing?
That's a tough question. There's this natural inclination to talk about how you want it to be lighter and microservice friendly, but I actually don't think that's fundamental. I think that's more of a job for implementations than for the specification of the language. Whether you get a faster compiler or not, whether the garbage collector is better, that's an implementation that you want to use or not, but it doesn't change what Java 9 or 10 or 11 is. I think that the main trends today around value types and arrays, and those are actually really important ones. And honestly, I think I would have preferred to have those before some of the things that we put in already, like invoke dynamics and jigsaws. But because I think those are more fundamental to using and performing in the language more. But again, it's a matter of taste. It is hard to kind of look forward 5 years and talk about features that I think this will pop up. And I think that most of what we're going to see is more evolved ways of using APIs and composing them together, maybe even using external services and composing them together in a way that crosses languages, it's not so much Java specific, but a good Java wrapper for the functionality and logic. If you'd like, probably get hit for saying this, but Java EE is sort of a very slow, stale, fat elephant that's not moving fast enough. And there are a lot of efforts out there to do smaller the Java EE that's still very useful for programming as a platform, small containers, microprofiles, things like that. I think there's a part of that needs to go into the SE platform. For example, we're sorely missing JSON handling capabilities that are standard. Yeah, there's 17 good implementations, but I'd like one that works everywhere and I don't have to depend on. And on top of that, taking more of the features that people think of as container features and making them standard parts of the platform, it is what we find in environments like JavaScript with Node and Python and other things, where the basic platform already includes basic capability that we think of as a container capability. I'd like to see more of that. But again, it's hard to develop an intuition for what the right thing is in 5 years. Slow and steady and keep it compatible and don't break things is more important, I think, for Java than sexy and cool and change every year.
Up here in the front of the room.
Yeah.
So a little bit back to the boilerplate concept. I'm a huge fan of Project Lombok. I don't know if you're familiar with it or not. It allows you to avoid a bunch of boilerplate in Java. Have you seen, or are you interested in seeing a lot of more development in annotation processors at compile time that can help alleviate some of those pain points?
So annotation processors are kind of an interesting two-edged sword. I think annotation processors for project-specific uses or outside of the spec uses are interesting capabilities. They kind of evolved on their own into an ecosystem or not. You could look at Spring as a good example of that too. But I see things that were in the platform, standard annotations, and the ability to rely on an annotation processor always being there as something I'd like to do. I've looked at various places where the only right way to do it would have been with annotations. However, since you don't have a built-in way to force the annotation processor to run everywhere the library is used, it's kind of clunky to put them in. Yes, it will work if you do these things, but it's hard for the library to require and enforce that those things will be done, which means that there's some unknown instructions posted somewhere on how to use it. Wombat certainly has that going for it, right? Or you can say it, or whatever you want to call it. So I think things in the platform that will allow you to incorporate the requirements of annotation processors for code to require the annotation processor to exist and pre-process the code before it ever gets loaded, and for verifiers to actually enforce those, for example. I think those would be useful. So something like Wombat could say, that code in some way in the declarations and the packages doesn't mean anything unless this processor ran on it. Because today the annotations are actually optional, and things break if you don't run them the right way.
Okay, last question. Go back here.
Hi.
Where is it?
Yeah.
Oh.
Nice talk. I just had a question. Anything interesting coming with the Java secure socket extension in the future releases, especially from an interoperability standpoint?
So the simple answer is I don't know. I really don't know. I have no idea. So I hope the answer is yes, but I really don't know.
So Gil will be around for about 25 minutes before the next session. Thank you, Gil. Great talk.
Thank you.